If you can hear that bird outside, just deal with it, because he's having a great time. This is a bit of a weird story. On October 6th, I won an auction for my digital DECWriter II. It took quite a bit of work to get it going for a few reasons, and the eventual video released on November 1st. But on November 4th, I realized I had an unread message from someone local who had offered me a DECWriter III back in September. I didn't see it until they sent me another message right after I released the video on the 2. Now, the 2 and the 3 are very similar. They're practically the same, except for a few key differences. The 3 is RS-232 from the get-go, and supports 9600 baud, which both make it drastically easier to use. However, I didn't really need 2 of these things. But that's a problem for future Shelby. So I met up with Andrew, who graciously gave me the DECWriter III and a few other curiosities that came from a business shuttering some old hardware. Now, I wasn't planning on making a video about the restoration of this DECWriter III. I thought I was going to do a quick stream where I reformed the caps, maybe replace a similar diode to the 2, and got it up and running. But oh boy, was I ever wrong. I'm looking at nearly 23 hours of footage of the restoration of this thing now, and it is absolutely a story worth telling. So this is how I spent nearly the last 2 months getting an extremely dead DECWriter III back up and running. On November 9th, the first day I picked up the 3, I had a plan all in place to mess with my stream chat and act like this was the 2 that now just magically had a serial port. That didn't last long because they're pretty obviously different inside, it turns out. Now, I could have turned it on at this point, because I was told by Andrew that he had tried to use it and turned it on before that, and it shows some signs of life. But I wanted to look it over first, because I was pretty burnt by the 2. The first thing I noticed was that the print carriage was stuck again. I was able to get some movement out of the motor and idle pulley though, so once again, the carriage itself had seized to the rail for some reason. The first step to fixing this was to get the belt off of the other gear so I wouldn't fight against him. Then, after some investigating, I determined that the impression strength cam bearing was what was stuck. I could move the lever and the whole unit flexes, but the rotation didn't make it through to the other side. I tried to loosen the rail itself to break it free, but the way it mounts is a pain, and that wasn't going to happen. So I settled on a less cautious approach. I applied some oil to the outside of the bearing, hoping it would seep in, which it did seem to, and then I used a wooden ruler to apply percussive maintenance directly to the stuck bearing, which worked. Now this one was so much worse than the last one. It took a lot more force to get free. But after that I cleaned the rails thoroughly and lightly oiled them to help prevent this from happening again. With that solved, I was on to making sure it was safe to power. Even though I knew it had been turned on recently, I wanted to inspect it first to be sure. And oh boy, am I going to have some stuff to talk about with this thing later. I thought it all looked good at first, and since it was powered recently, I will admit I didn't look it over all that well initially, but as I was reinstalling it, I caught a whiff of the smell of a leaking cap. I immediately took it back apart and looked closer. Not only was there a bad cap, it was failing in the same way that the big cap from the HP 7475 was, where the electrolyte had crystallized and seeped up the jacket. This ended the process for the day, because these needed to be replaced before I could safely continue. Now, there are 2 other things about these caps. They look like axials, but are actually radial with a third leg on top for mounting like an axial for added support. There was no reason for these to be used here, and I have no idea why DEC picked them. DEC made some other very stupid choices in this power supply that we'll see later, but I have Andy to thank for pointing out these series of caps which prevented me from ordering the wrong replacements. Now the other thing was with their replacements. I placed a big order with DigiKey the next day so I could get them as soon as possible, but the region where DigiKey is got walloped with a massive blizzard right after that delayed my order, so I wasn't able to get back to this repair until the 21st. When I got the caps in, I was raring to go to get this thing up and running. I ripped out the PSU, making notes of all the cables and screws, got it up onto my workbench, and started pulling the caps off. This is when I found the second of many questionable choices by DEC on this power supply. The legs for every single part were folded over before they were soldered down. This makes it so much harder to remove them because you have to bend the legs straight while heating them because you can never really get all of the solder off with them bent. It's not impossible, but it really slows the process down as you work on it. I finally got the first cap off, which wasn't the bad one. There were 2 identical value parts and I was replacing both of on here just to be safe. This was my first unobstructed look at one of these weird 3-legged caps though, which it turned out the green ones beside these were also the same weird pin style. Again, no idea why. Then I started tackling the bad cap. It was obviously very far gone once I got it out. My apologies about the poor video quality. I still wasn't planning on making a proper video out of this at this point, and I'm relying on my stream VODs for just a little longer. But this cap was absolutely wrecked. I got the replacements installed for them thankfully much quicker. And while I had the board out, I figured it may not hurt to pull off the 2 giant caps on here and do a quick reform on them. With the device having been recently powered on, there wasn't a huge reason to do this, but it wouldn't hurt. Now, I'd recently been messing with some of my test gear before this and didn't have my full reforming setup available, so I decided to just connect them directly to a power supply and slowly bump up the voltage. This wasn't my preferred method, but this was low risk. But I wasn't as familiar with what to expect from this, but it didn't seem outrageous. They clearly weren't shorted and got up to voltage just fine. Now, obviously, I'm only mentioning this because we're going to find out these are bad later, but this is a pretty common way to reform caps for most people, and I saw nothing out of the ordinary here. We'll see how I determine these are bad later though. For now, back in the PSU they went, as I was finally getting ready to power this thing. A quick side note though, I started wearing gloves to handle the power supply from here because it has a really unpleasant texture for some reason. Not because of the cadmium plating, which is safe because it's an alloy with zinc. You wouldn't want to weld on it though. Back to the power-up, I was fully ready with the thermal camera this time to catch any problems after I roasted the solenoid on the 2, but it revealed nothing and it all looked completely fine. It powered up and idled waiting for input without any issues. Took me a bit to figure out how to put it in local mode, but once I did, it started printing to the paper, before it immediately did something strange.
We will have a dead bad ribbon in here, so don't expect any miracles here. Line feed. Has auto repeat, interesting. I'm gonna go down. Okay. Ooh, it tried to home and it failed. Yeah, it's not liking homing somehow.
I had to call it for that day, but when I got back to it the next day, I started off by trying to look in the manual to understand how the homing worked. I'm going to make a long story short here though, and just tell you that I was barking up the wrong tree. The head homes just fine using a sloppy method of watching the optical encoder on the back of the motor. It slams the head into a bumper, and once it sees it stop moving, it knows where it is. After a bit, I shifted my focus to checking the power rails. Like the DECWriter II, the 3 has a 5 volt, plus a negative 12 volt, and plus a negative 24 volt rails. After more prodding, it seemed like the logic was possibly browning out while typing at random, and I wanted to watch the 5 volt rail to see it dip. I tried using my Fluke 287, which has a logging mode.
Look, we have an oscilloscope at home.
But it wasn't very fast. I could have tried to use a Tech TDS 320 I have in roll mode where it charts in real time, but I wasn't super comfortable with going down that route with potential grounding issues. And the reason I was messing with my test gear previously was because I found out this scope had some issues at different sample rates. Coincidentally, I was also working on a Craigslist deal for a new handheld battery oscilloscope, which would solve all of these problems, and I would be picking it up that day. So I figured I would just pause here until tomorrow so I could work more safely with better suited tools. On to day 4 now, November 23rd. I got the scope and it is pretty awesome. I did a second channel video looking at it if you want to know more about it, but it was exactly what I needed for this. I got it connected to the 5 volt rail and could absolutely see it sag when the system seemed to reset.
So local, type, and it already died.
It was definitely browning out for some reason. This is when I moved the probe over to the 24 volt rail for the solenoids and was greeted by an absolutely massive 4 volts of ripple.
That's a lot of ripple.
This is evidence of the filter caps on that supply failing and the switch mode's natural ripple getting through. After more testing, it turns out the system was specifically browning out on characters that used all 7 pins on the head at once.
Lowercase p, fine. Uppercase P, dead.
It had to be collapsing the output of the switching so much that it was impacting the other taps in the transformer because the 5 volt rail is completely separate. The main caps that filter the 24 volt rail are, surprise, the ones that I put on my low quality reforming setup. I promptly yoinked those off the board and put them on my LCR meter to discover that they were completely worn out.
So are these just hollow now? Are they just just vaporized inside?
This is a 14,000 microfarad cap, reading as 67 nanofarads. Now the real kicker here was the voltage rating of these caps. For the 24 volt rail, DEC spec'd 28 volt caps, only a 16% overhead. That is not enough to account for manufacturing variance or voltage spikes. I saw a similar problem with the 8200 microfarad cap on the 5 volt rail that was only 6.3 volts. I pulled it off and it was trashed as well.
Is it that toast? Are you kidding?
And this is the point that I should mention what I think the history of this device is. When I picked this up, I was also given a CRT from the same room that the DECWriter III was used in, and it has the worst burn-in I have ever seen in my life. So I genuinely wouldn't be surprised if this machine had been left on for decades. I've never seen capacitors in this bad of shape that are just degraded from use. Going back to my video on capacitor reforming, I showed a failure mode chart from Nippon Chemicom. These capacitors' weak states are the result of natural reduction capacitance from consuming the electrolyte as they continuously maintain their oxide layer through forming in circuit. In a way, this is the ideal failure mode for a capacitor, but they usually fail through some other means first. Given this information, I deemed every capacitor in this power supply dead and in need of replacing, with the exception of the main side caps. As usual, they were somehow completely fine, despite the likely massive usage.
That's bang on. Finally, one that's good. Okay. Whew.
This meant yet another cap order was needed, but I don't feel bad about it because there was no way I would have ever preemptively ordered the 14,000 microfarad caps because they cost me about $20 each, and I didn't test them until I replaced the other caps since this had been powered already. Anyway, to add insult to injury, the second cap order was also delayed, and it took a while to get back to this. Day 5, December 6th. I now have the caps in and can start rebuilding the power supply. Of course, all of the other caps also have their legs folded over, and between that and the power in my office getting shut off from construction, I didn't get all of the new caps fully installed until the next day. I would like to draw attention to the very weird replacements I got for the big caps that have a stud on top of them for some crazy reason. Well, maybe not that crazy. This is what HP should have used in that 7475 since they abused that cap for mechanical support. There were, thankfully, no more crazy revelations during the recapping, but I did come up with a cool way to use my hot air station to warm the board more evenly as I was soldering the giant ground planes with the bent pins. After that, I put the newly refreshed power supply in, fired it up, and immediately measured the 24-volt ripple. With the new caps, it was only 80 millivolts. The 2-volt peak-to-peak is from the transient spikes from usage. This was wildly better, and the machine now no longer browns out when using all 7 solenoids at once.
I think we got it. Oh, I guess there's no repeat key. You just hold it. The future.
I was feeling pretty good, but there were a couple more things to take care of still. And when I first got this, I noticed that the ribbon under the head had a hole blown through it, and it turned out that the ribbon wasn't advancing. I didn't really notice this until I put a new ribbon on and tried to type, but also because the machine was completely non-functional until now. Another problem I saw were the pins hitting very inconsistently. First, the ribbon though. I started poking around the mechanism and determined that the clutch wasn't properly engaging for the ribbon advance. But if I applied external force to it, it would catch and move the ribbon. One of my viewers, Playful, had a feeling that it was a sprag clutch that can be easily contaminated, and that is what it turned out to be. There are needle bearings inside that are pushed out with springs that clamp onto a shaft in one direction. The manual for the DECWriter III says to douse this whole area in oil, which means this probably needs regular maintenance that it never got while it was whiling away for decades. I had to clean this out with alcohol and flush it out with new oil. This got the mechanism working just fine, and the ribbon advance was now functional.
It like works and stuff now. Crazy.
The pins, though, were a whole other level of issue. The top pin and the second pin from the bottom weren't striking the paper as hard as the rest. I shined a light onto the head from the side and saw that the pins were very uneven.
Dude. How?
I pulled the head off and got a better look at it, and they were completely misaligned with totally random depths. I was not ready to tackle another print head again, though. I learned with the DECWriter II that I really needed the correct size tools for this. And having just gone through this process recently, I knew it wouldn't be easy and wanted to be as prepared as possible. So this made for another breakpoint where I needed to order stuff to continue. Day 7, December 10th. I got the new tools in, mostly a smaller wrench set so I could grab onto the jam nuts to hold the solenoids on, but I also tried to get tools for rotating the solenoids themselves. They are completely smooth with no tool fittings at all, only a slot where the wires come out of. I tried a loop strap wrench, but it ended up just slipping. And I also got some flat shoelaces thinking I could come up with some leverage way to use them, but I couldn't get them to stay tight enough to be able to twist. In the end, it didn't matter though, and that's not a good thing. On the DECWriter II, the nuts were loose and the solenoids were stuck. This time, the nuts were stuck to the solenoids, and bad.
Let's just see how bad. Oh, that's fun. After I break this loose. Oh. Well, that is not good.
There was some kind of residue on them as well that I never identified, but I think it seized up everything really badly. I ended up just backing out the solenoids by the nuts, but this meant that I couldn't change the depth of the nut, which was what sets the pin depth. I managed to wedge a tool in the slot of the solenoids that let me just barely move the nuts on them, but that wasn't easy and slightly damaged them. At least for the top ones. The bottom ones were completely stuck. I couldn't get anything to move them at all. In addition to the nuts being seized, the top side solenoids are in the way of the bottom side nuts, and I had to remove all but 2 of the solenoids, which is awful. That means that I'm going to have to rethread all of those tiny pins back through the head, but I had no choice because they were completely in the way. I actually went out and bought some PB Blaster and came back to try and break them loose chemically. After letting it set for days with the PB Blaster on it, I eventually got it down to just 1 final stock solenoid left, and 1 more I left in loose so I didn't have to rethread it. But the final nut would just round off with the tools that I had, so I decided to stop and think about my options from here. I'm leaving out a bunch of other stuff I tried that didn't work, but I settled on a flare line wrench being my last option before I gave up and damaged something. These are wrenches that grab on all 6 points of the nut at once and reduce the stress on them. With this, if I rounded the nut completely smooth, that means I am applying a ton of force to it. And you also have to keep in mind that the threads that this is stuck on are on a hollow tube that the pin goes through. So even if I could turn the solenoid with a tool, I might crack it if that is what is stuck, so I was trying to find the right balance for a solution here. I eventually decided to order the line wrench set, but I knew there would be one more problem when it got here. Day 9, December 14th. This is the wrench, and this video looks weird because the wrench is too thick to fit under the solenoid at all, let alone between the solenoid and the nut. So I'm going to grind it down. To avoid damaging the parts, I'm going to destroy this tool. I spent an hour on this, going back and forth, slowly grinding the wrench down, making sure I didn't get it too hot or making it unevenly shaped, and checking the fitment on the solenoid. There's really not a lot to it, but I figure the more I talk during this section, the more we can see cool time-lapse of sparks flying. Oh yeah, the video looks bad because I put a cover over my phone's lens so I didn't damage it with the sparks. Well, alright, that's probably enough. While I was waiting for the wrench to be delivered, I noticed that the weird residue was underneath one of the nuts I removed in a photo I took. So before I made my last attempt at loosening it, I decided to use soap to try and break down what might be oil and used a box cutter to try and break it up along the edges of the nut. After that, I gave it a shot with the line wrench and... nothing. I rounded the nut even worse on all sides now. It's just completely seized. This was the time to accept defeat and walk away. Anything more I could do to this could cause irreversible damage. So I went ahead with reassembly, and wait a minute. The last pin, it's perfectly aligned. That pin absolutely wasn't that flush before I started, and I think I may have just barely rotated the solenoid itself. Whatever, I'll take it. This is far from the end of the work, so I'll accept an easy win. Now I have to reinstall every single pin in the solenoid. I numbered them all before I removed them, and I'm cross-referencing that to the service manual to know which ones go where in what order so I can install them all correctly. I'm having to feed the pins through the channels and into one of the 7 positions right at the very tip. And once I get it up to the tip, I then have to move the jam nut until it bottoms out at the right depth for the pin. This is all too small to see in person, and I'm using a high-power macro setup with the print head in a vise to keep watch of it as I go. It is incredibly fiddly. The nut sticking to the threads was also making this very difficult, and it didn't go as smoothly as I would like. Some of the pins are not as well aligned as I was hoping, but by the end of it, it is miles better than it was before. Now, after an hour and a half of messing with just this, I ran into one final issue. The topmost pin's channel through the black blob is causing friction on the pin. Here, I went back to test it in the machine, and the top pin was still very weak. I used some fishing line to try and floss out the channel and drench it in PB Blaster oil and alcohol multiple times to try and free it. I eventually left it soaking in PB Blaster overnight one last time in the hopes that it would break up whatever is making it weak, but ultimately, that didn't work. But that's it though. I'm calling it here. There was nothing more left that I could do from here, so all that's left is to put it back together and try it for real for the first time. So let's join in with me on the last day as I'm about to put the head back in the machine.
All right, I will not
be surprised if I still have issues with that top pin, unfortunately, but let's see what it looks like now. All right, moment of truth, because this is probably the last thing I am attempting. You know what? It's weak, but it's not horrible. I could push it forward like one more click or so, maybe two. And then it's a little more consistent, but I know I'm slamming those bottom pins in a bit more than I would like, but maybe I just do that since in reality, it's not like I'm going to use this all that much, although maybe that sounds okay. Because when it's way too close, I can hear that they don't move enough. Yeah, they don't even strike as hard when they're that close. So there's definitely a balance. Well, the only thing left to do from here is to put it all back together properly and then try connecting it to a computer. And there we go. That is the DECWriter III done. That was a lot more than I thought it would be. I literally thought I was going to get this done in the first weekend. Okay, I'm still trying to set up for the next part where we try and communicate with the computer fully here. It's kind of a nightmare to set up serial stuff, so this is the adapter chain that is currently working because Serial is awesome. And I just had a moment where I sent it a test message to make sure that it's actually working, and it's just absolutely insane. Gosh! It's so fast and brutal. This thing is going to be incredible. All right, we're finally ready to check out the DECWriter III in action as a terminal. Now, I have it connected to a computer running Linux here, and we're going to connect to this in two different ways. First, I'm just going to show you how you can use it as a printer, and I'm going to demo sending information to it. Then I will show you how it can be used as a full interactive terminal. But first, let me show you how we set it up, because this thing is kind of cool and weird. Okay, so on the keyboard over here, we have this little plaque that tells you a bunch of information about how to configure this thing. That's what all of these are. Now, these letters tell you what different setup options are. To get into setup mode, you hold Control and you press Setup. The setup LED over here will start blinking, and the display, actually, I forgot to mention this, it has this incredible little bubble display down here, will tell you what you're doing. So the first thing we will need to make sure that we have set up correctly is the baud rate, which the plaque doesn't actually tell you how to set up, but that is 0. So here we can see we are at 9600 baud. Now, when I first turned this thing on, it was actually at 1200 baud. That's what that demo I showed you a moment ago was. But we can press 0 here again to cycle through all of the different baud rates it has. And oh my gosh, 50, that's just ridiculous. So it supports many different ones, but the DECWriter 2 tops out here at 300 baud, which is kind of really bad. That's a lower baud rate than the USB serial adapter I'm using for this actually supports. So that's one of the reasons why I'm so excited about the DECWriter 3 over the 2. And I did initially want to get the 2 going in this video so that these can try and communicate with each other, but this one's RS-232C and that one is current loop. So they literally can't plug into each other right now. I have an adapter and plans to make the DECWriter 2 compatible with this, but it's going to be a lot more work. So we'll put that back at 9600 baud. Then we want to set the parity. Now, it's a little weird here, and you'll see over here, it actually says parity C manual, because this number does not indicate quite the exact thing that it's doing. 8 means that it is 8 data bits, none parity for both transmit and receive. You can actually set different parities for transmitting and receiving, which is really weird. We're not going to change that at all. Now, there are some other things you can set, like local echo, which would be kind of half duplex mode if you wanted. But everything else here is configured correctly for how we want. But there are a lot of options you can go through, and you just use Control and Setup to get into this menu. To exit, we just press Setup again. From here, we can start to use this thing with a computer because we know how it is set up, so we know how to configure our serial interface with it. So this program is QCOM. This is a very simple terminal interfacing program that just sends really basic commands to a terminal device. It's pretty useful for doing stuff like programming devices that take commands, and I just like to use it as a quick test. So that message I was sending earlier was this, which is just so insanely fast. But we can type whatever we want in here. Computer. I don't use the keyboard on my laptop all that much, and the keys are like doing double presses now, so that's fun. But anyway, I'm just gonna send it. Oh my gosh, it's so fast! That's just insane. But that's just straight printing. That's really cool, and I'm going to use that later at the end of this video. But one of the really cool things that this can do is, well, this whole thing right there, it's not just a printer, it's a whole terminal. So let me show you how you use it as one. Now as root, we're going to run a program called Getty, which will provide a serial terminal interface over a specified port. So we're going to use a Getty, which is a modern version of this, and then we tell it the serial port that we want to use. A Getty is a little weird because you don't provide the entire path to the port. You actually have to provide it as a relative path to the dev device folder. That always trips me up when I'm trying to use this stuff. Now, as soon as I press enter here, this will immediately become a serial TTY. It's ready for me to log in. Oh my gosh, it's so cool! It's just ridiculous! Okay, so here's the thing. It totally works. So if I do an ls here, it's gonna print all of the files that are in my home folder. I didn't know it was gonna do double direction printing. Oh my gosh, this thing is awesome. This thing is ridiculously good. This is one of the best vintage terminal experiences I've had on a modern computer. Now I didn't actually specify a particular terminal interface here. So let's just, for kicks, echo term, and see how it set it up. So it set it up as a VT102, interesting. So I was wondering what terminal interface codes it should use. Since it is a DEC, it would be similar to the VT100 series, I imagine. I don't know how similar it is because I don't actually remember when that terminal came out, but it looks like it's close enough that this is gonna work out well. All right, now we do have some problems here. Because this is a hard copy terminal, it means everything that we print is gonna show up on the paper. And we can't use something that is a curses type application on here without it doing weird things. So just for kicks, I'm gonna run Vim, but we're not actually gonna be able to use it. Oh my gosh, it's so much worse than I thought it would be. So yeah, we can't use all of the Linux applications that are out there because it's gonna do really weird stuff. So let's just quit Vim, and there we have our terminal back. That wasted a whole sheet of paper, not unsurprising. All right, let's go ahead and line feed so we can get up to the next line. Oh my gosh, this is so good. Now I can do something like this. If I go cd git, all right, I can cd rt 4K remote as an example here. This is, well, here, I can just show you. This is a repository I have been working on that is a remote web interface for the RetroTink 4K here. So we can run git log as an example. I offset it by, oh, that was worse than I thought it would be. Beep, beep. Oh, I didn't realize git log was interactive. Okay, so that's not good. We want to quit that. Man, everything is just using curses, isn't it? This is rough. Yeah, but if it hadn't been a curses application, that would have just worked normally, but apparently it was. Yeah, this is the whole problem. For kicks, we can just cat rt 4K remote, and we can print the entire file to the paper. Oh my gosh, why is it doing whole page breaks? Why? Stop it! Oh my gosh! This is the danger of doing this stuff. I mean, I can... It has its own internal buffer. I can't stop it. There we go. Yeah, it's hard to use Linux computers with this kind of thing because it's all the software is using more complicated protocols now. So I will revisit this, but it's going to take getting a very specific set of programs whitelisted that won't do horrible things like this, and probably trying to figure out how to make it work. It's possible that it running in VT102 mode is sending like a screen clear command. It's trying to redraw from the top or something. I don't know. So I might have to look into like a raw ASCII terminal interface, or maybe there is a dedicated hard copy one. I don't know, but that gives you an example of what using this as a Linux interface is like. Well, it's been DECWriter 3 fully functional after just an absolutely insanely ludicrous amount of work. I genuinely cannot believe it took that much effort. That was ridiculous. But there it is, fully functional. I know better than to try and hunt down all of the Linux configuration stuff to try and make this thing work better right now for demonstration, because it is not well documented anymore. This is actually a thing that I just complain about all the time. Linux terminal entries and Linux terminal support is really bad nowadays. Most people hard code the terminal escape sequences. So what I'm really going to have to do here is use something like Screen to wrap the escape codes from the terminals to make it interpret them correctly to work with this thing. And it's going to be a whole trial and error situation to try and figure out what the best setup's going to be. So it's not going to be easy to make this work with Linux, but it should be possible. But it's still so insanely cool. I will be able to connect it to the data generals back there. You're probably wondering why I didn't do that yet. It's because the serial card in that is set up for 19,200 baud to print much faster to the Dasher terminal, which also supports that. I have to pull the card out and reconfigure wire jumpers on it to reduce the baud rate. And I will do that once I mod that terminal to also work, because I'm probably going to set it to be 300 baud on the data general. That way that one can work with it as well. I might even just use that one as a dedicated printer with that thing. So I have a little bit more work ahead of me with these. This one, we need to figure out what the Linux software is going to look like. That one needs a serial mod, and then I will connect them to the Micronova and get it printing through at least this, but hopefully the DECWriter 2 as well. But that is all for today. Oh, I'm really glad to finally be closing the book on getting this thing working, because this has been like a 1.5 month long project. Absolutely insane how many things I discovered one after another, repairing one piece at a time. The most strung out, ridiculously long project I've had in a long time, for sure. So yeah, definitely glad to be putting that one behind me, but I'm so excited that it works. Well, if you enjoyed this video, you may want to subscribe to be notified when I release another one. If you want to help support the channel, you can find me on Patreon, but for now, that's it. Now, let's see it print.